Tenakoto katoa. Welcome to the SOLA seminars. Today we have a very special talk because I don't know if you guys are all aware, but this past year we merged, landscape architecture merged with the applied computing department, and we have grown as a family. So part of that celebration, we have invited Stuart and Pat to give us a quick lecture and talk about what kind of work that they do. And hopefully in the near future, we will have more talks that will combine both departments and both topics. And hopefully we'll have some of your students as well, and some of your professionals come and join us on these seminars. So without further ado, the floor is yours, and we'll open up for questions at the end of the talk.
Thank you, Nada. So I'm Patricia Anthony, and over there is Stuart Charters, my colleague. So really what we would like to do today is to share with you one of the work that we did with M.Fortunatus, which was a student of ours, was it 2 years ago, and this paper was the outcome of her master's, which we actually presented in a virtual conference last year. So this is just a version, a slightly longer version from what we had presented, and we will try to keep it simple and short, and hopefully not talking too much about the technical side of things, so that you understand the value of the research, rather than be bored with all the formulation and how we actually get to the actual result. So I'm sure all of you have heard of cyberbullying. Yes, because all of us are always on our phone and we're always texting someone, and often we do say bad things about other people. So what we will do is to for the next 30 minutes or so, we're going to introduce you to cyberbullying, some of the work that have been done with respect to detecting cyberbullying, the method that we use, then we'll show you the results and the discussion and conclusion and future work. So Stuart will take up, we'll talk about the method, the result and discussion, and I will take you to the introduction, of what this work is all about. Okay, so like I said, I'm sure you have heard of the word bullying, if not cyberbullying, right? So there is another term called cyber aggression. So it's just that we are in this digital world that everything starts with cyber. Okay, so cyber just means that you're in the digital world. Okay, so basically, cyber aggression is actually a voluntary act of violating another human through technological communication media. So be it through your emails or your smartphone or your computer. So really, the cyberbullying is actually defined as the repetitive act of cyber aggression. But we use these two terms interchangeably, that when we say cyber aggression, it actually really means cyberbullying. Okay, so cyberbullying cases are very prevalent nowadays, and often we hear in the news about cyberbullying and how cyberbullying has driven students to committing suicide, mental depression, and not performing well in school. So cyberbullying as it is very prevalent in young people, especially in school age, because technology has become more central to young people's lives. People like you guys who use a lot of the technology. It was reported that nearly 1 in 5 students have reported being bullied during their school year. So this is a very important issue. 18%, so according to this study, 18.2% admitted to victim of cyber aggression at least once a year, and this is a documented fact. In 2014, based on the study by Pachin and Hinduja, on average, 24% there are 24% victimization of cyberbullying. So it's quite alarming, actually. So like I said, cyberbullying is not a good thing because it does affect the victims of cyberbullying. So there are a few effects of cyber aggression. So one of which is depression. So we know that when students are bullied, they usually become very depressed and they don't know what to do. So they go into depression and they have some mental issue. Sometimes they resort to substance abuse, so because they're depressed, so they have to, to do something else to not to worry about being bullied. And in the worst case scenario, there are suicide attempts. Okay, so some actually even resorted to suicide just because the message or the message that they get are really bad, so that they they have to do something about it. Okay, so the effect of cyberbullying is just as severe as a traditional bullying. So in New Zealand itself, the estimated incident is reported as the third highest of the 29 countries surveyed by Ipsos. So what is Ipsos? Ipsos stands for Global Market Research and Public Opinion Specialist. So let's say they do market polls and all of this stuff. Okay, and the trouble with cyberbullying is that often they are very reluctant to report incidents of cyberbullying. Okay, so it is because they're worried that if they report it, because remember, these cyberbullying incidents are very prevalent among young teenagers, young people. So if they think that if they report cyberbullying, they will have their electronic devices taken away. Okay, or sometimes they're anxious that they might not be taken so seriously. Okay, they also fear that nobody will be able to stop it from reoccurring, and that's why they often don't say anything. And they're also very skeptical that perpetrator will not. They're skeptical that perpetrator will be punished. Okay. So the trouble is that social media is a platform where it offers anonymity and freedom of speech. So anyone, anytime, anywhere can actually post anything about somebody else. Okay. So if you're not happy about your friend, if you don't like your friend, so what do? You go around posting, fake news or not a very unpleasant message about that person. Okay, so if you do this repetitively, this can be tantamount to cyberbullying. And of course, when that happens, what others will do is that when they see a message, what do we do usually most of the time? If we think it's interesting, if we think that it will amount to something, we share it. We copy and paste and share it all over the world. So that can become really extreme. So cyberbullying is used by irresponsible parties to demonstrate unacceptable behavior. So long as you don't like someone, here, social media is the right avenue or the best avenue to actually, discredit another person. Okay, and it is very rampant because we can use a lot of non-verbal cues. We don't even have to say it very precisely in text. We can use gestures and facial expression. So this is in the form of your emoticons and emojis. So there's so many different types of emojis or emoticons that one can use without even having to say a single word to just discredit someone or to bully someone. Okay. Because of the downside of cyberbullying, and because we are concerned that the victims might be driven to doing something drastic like suicide or depressed or mental health, it would be useful if someone can actually troll all of the Facebook posting, Twitter posting to just try and see whether someone is being bullied. But do you think that's actually possible? Probably not, because there are so many posts, that it's almost impossible because the large number of posts that you have available online. Okay, so more often than not, we do this, but like I said, the manual one will not be able to cover pretty much all the posts in the world, okay, in the social media. So it's almost impossible, and the only way is to actually resort to having an automated detection. So that means relying on computer programs, relying on special software to actually tell you that there is a cyberbullying going on, and once we detect it, then we can actually react on this. Okay, so the purpose of doing detection is that so that we can detect that there is cyberbullying incident going on, and that measures should be put in place to prevent and to stop the cyberbullying. Okay, so of course one can argue that there's a lot of social anonymity in social media, and you probably don't know, who's posting it, but at least we know that there is some element of cyberbullying, and maybe the person or the victim can be counseled. So with that motivation, we thought that we want to experiment whether it would be useful to develop some kind of computer program to develop to analyze social media posts that has a combination of text, emoji, and emoticons, and find the elements of cyber aggression, and then flag these posts as being something that the authority or whoever's in charge should be looking at. Okay, so there are some related work. So there are works that have been done by other researchers out there in terms of cyberbullying, but we found that there are not a lot, so it's still a work in progress, and we expect to see that there will be a lot more of this particular type of work going on in the near future. But cyberbullying itself, detection, can be considered as an extension to sentiment analysis tasks. Who here have heard of the term sentiment analysis? Well, that's fine. So basically, a sentiment analysis is a computing term that we use to describe an automated process of classifying a text as a positive or negative. So it's something like, I do not like this bottle. So when I say I do not like this bottle, that means it's a negative sentiment. If I say I like you, that's a positive sentiment. So a sentiment analysis is an automated process of trying to read a text and decide whether this is a positive or negative. So if we talk about cyberbullying, most often it's actually a negative statement. So the idea is that we use this existing technique and actually implement it to cyberbullying to try and detect the negative tone of it. But of course, we need to do a lot more than just distinguishing whether it's a negative or positive. So in my example, I do not like this bottle, does not really mean that it's a cyberbullying statement. But then when you add in some other additional statement that says you're a whore, or you're a nutcase, you should kill yourself, that's when it becomes a cyberbullying statement. Okay, so when we use this technique to detect cyberbullying, there are a few. So actually, in trying to detect cyberbullying, there are few methods, standard methods that we can use. So one, of course, is a rule-based method. So basically, it's just using some kind of rules to determine the sentiment of a given input. So if you see like, all those foul word, foul language, then you can say that's definitely, or that's most likely a cyberbullying statement. Okay. The second one is what we call a lexicon-based method. So we use some kind of lexicon or a dictionary. And so we use a dictionary, and then every time we see a word in the sentence, we actually compare it with the dictionary. So if we're looking for swear words, slang, disgust statement and all of this. So I don't have to say it because it's really gross. So I think you know what I mean, right? Okay. And so basically, you might think it's easy to process a text, but it's not, because, how do you write your text, or how do you post in your social media? So you use short form, emoji, notation, WF hedge, FFS, and those kind of things. And you don't expect the computer to know it because, they don't know what is FFS, but if we look at it, we know it, right? So there's some processing that needs to take place before we can actually go on and identify all these elements. So, so when we take in a text that we mine or we extract from FB post, for example, we need to tokenize them, so you have a whole sentence, we need to tokenize them, break it down into words, and then resolve all the slangs and swear words, and then only we can apply some kind of rule or pattern-based matching. Okay, so, but there are available dictionaries that we can actually use online, so which is a good thing because somebody has already done this work before. So the other technique that we use is what we call machine learning. And this is where we build a model, we train it with existing terms that we have found. And then hopefully, once we train it, just like when you go to school, you learn something and you sit for an exam and you pass it. So it's the same thing with machine learning. You train it and hoping that you train it well and then it does the job properly. So again, it's like a black box. You don't have to worry about what's going on inside. We use some fairly complicated process inside there. But basically, the idea is that I have this text, I put it through my machine learning box, and then it should tell me whether it's a cyberbullying or not, pretty much. But yeah, there's a lot of other things that goes on. So some of the notable research, okay, in 2011, this Reynolds, they did cyber aggression detection using RuleBased, and you know what RuleBased is, and a bag of word model. That means just separating all the words in all the sentence into words, and using data from formspring.me, which is also a social media in the olden days, but you probably don't find this anymore. It's not as popular as Twitter or Facebook. Okay. Then there was another work on detecting cyberbullying online chat, so using rule-based. So you can see that even with using a simple rule-based method, you can actually detect cyberbullying aggression or cyberbullying elements. Okay. But of course, the accuracy might not be as close as 90%, but it's good enough. If you can say, even if it's 60%, we know that there is something that you can go on. Okay, so then another one, detecting harassment, again, using data set that they extracted or mined from different social media. Okay, I'm sure you have not seen this name before, congregate/MySpace, because again, that was 10 years ago. Well, is it? Yeah, more than 10 years ago. So that's probably been closed down. It's now not, not being used at all. Okay, and then they've also used some more sophisticated technique like the machine learning. Okay, and this one here, because it's a fairly recent, they extracted the data from Twitter. So how many of you use Twitter? No one? I don't know. I'm sure you use Twitter, or at least Facebook, right? Facebook would be the most popular one, right? Have you ever seen, so have you ever been to Donald Trump's Facebook page? Okay, yeah, yes. Oh, that's right. Maybe we should try Melania Trump. Oh, we should, okay. Well, the idea, so basically when this student was actually doing this work, Maisie was doing this work, Donald Trump was the president, you see? And so, Donald Trump is not a very well-liked president. And so when we troll his Facebook page, there were just too many, foul language, and then of course there are the fans, but then, it was a lot more negative than positive. So then we said, oh, maybe we shouldn't do Donald Trump because it's too much work. So we went to the wife's page, Melania Trump, and that was even worse. But yes, and the data set we actually used was from Melania Trump's Facebook post. Okay, so what are the challenges in detecting aggression in text? Well, there's a lot of ambiguity, lack of non-verbal cues, and then, like I said, we use a lot of emojis. But okay, it's always good to know that somebody has actually compiled a set of emoji sentiments. So that one that says this smiley face is positive, this sad face is a negative. So it's a lot easier because somebody has actually put it in a dictionary so that we can then just refer to it. If it wasn't available, then we would probably have to come up with one, but this is not the case. So which we are lucky indeed, because otherwise it would take forever. And then there are also, because we are processing natural language, okay, English natural language here, because I mean, if you do Chinese or some other language, it might be a completely different process, but this one we focus on English, okay? So one of the linguistical limitation include misspelled word. So we don't type you, Y-O-U as, you as that, we say you. And sometimes we make mistake, cake can be spelled as C-S-K-E. So the meaning of the sentence cannot be implied if you have this kind of misspelled words, okay? And often people like to use elongated words. So I love you, I like you, you know. So if you check this against the, I don't know, Oxford Dictionary, you will never find a word that looks like this. And hence, you cannot detect the sentiment or the aggression because there is no such thing like that in the dictionary. So we have to resolve this. So what do we do? Well, again, write another set of code to remove all the repeating one. But you might think it's so it's actually very challenging because you don't know where to cut. So if you see multiple EEE, then I know I need to remove these duplicities. But how many times? And when do I stop? Because there are some words that have EE as well, which is legal. So yeah, we need to worry about this, and then we also need to worry about the slang. So we call this a not in vocabulary words because they are not really in the vocabulary. These are vocabularies that are created when social media became prevalent. Okay, lol. What's lol? Laugh out loud. So we have to resolve that. ROFL, roll on the floor laughing. Again, you know, we need to be able to expand that rather than just keeping it as is. So just some of the linguistical limitation and the challenges that we had to worry when we are processing it. Okay, so when we are writing a model, okay, how do we know that our model is good or bad? So we need to have some kind of performance measures, you know, how good is good? What do you mean by good? You know, just because you're able to detect 4 out of 5 doesn't mean that my model is really good or my software is really good. No, not really. We need to be a bit more comprehensive than just saying I tried 4 out of 5. So we need to test it with a lot of data. We need to make sure that we cover every single aspect of it. Okay. So we use something called accuracy, precision, recall, and F measure. Okay, so don't worry if you don't understand this bit. But really, if you are predicting something, so if the actual, so the value is the actual, so we are just doing classification, yeah? We're just saying it's a positive, it's a negative, or it's a cyberbullying, there is a cyberbullying element, or it's an innocent statement, okay? So here we have positive or negative. So if you're able to guess it, then it's called true positive. If you are able to, if you say that the positive is a negative, it's called false negative. And then if it's a negative, but you say it's positive, it's false positive. Then if it's a negative and you did guess it as negative, then it is a true negative. So that's what it means. And so what we do is just play around with this different numbers, and we get this measurement. So 1 being the accuracy. So that's just saying if I have 1,000 sentences, and out of that 1,000 sentences, I was able to accurately predict 90 of them. So that's 90 out of 100. So the accuracy is obviously 90%, right? So you might think, yes, that makes sense. You know, yes, that's what you do. You know, if you answer if you're in exam, right, and you answered 9 out of 10, so you get 90%. So it might be true in the exam situation, but actually in accuracy, it's in this particular problem, it's slightly different because, you know, what happens if I have 96 positive statement and I have 4 negative statement, okay? And my software has accurately identified all the 96. So does it mean that my accuracy is 90? So it means that my accuracy is 96%, right? But what are we measuring here? We're just measuring how many times we got it correct. But actually, 0% of the time, I was not able to identify the negative statement, right? Because the 4% was never counted for. So we're saying accuracy might not be the best way to measure this when we say that our software is good. So we have other things like precision and recall. So this one here, the precision is to say how well can the system identify positive inputs, avoiding the false positive, and the recall is really how many can the system correctly identify, how many can the system correctly identify positive input. And really, we want to look at the F1 score because it's a balance between precision and recall. Okay, so don't worry about the formula, but basically that's what we do. Okay, so like I said, once we have built our model, then we need to test it we need to train it first so that we know it works well. And then once we know it works, then we go out and do the testing. Okay. So for our data collection, we use Melania Trump's Facebook post comment. I'm not sure whether it's still available. So, I mean, feel free to go to Melania Trump's Facebook post and see what's being posted. But I've just extracted 2 of these, and I'm not going to even read it. You can read it yourself. But that's the kind of post that you get in her Facebook page. Okay. So we didn't want to spend, because this is a master project, we didn't want to mine so many data sets. So we had 200 random entries to train the data set. And then we got somebody to actually manually annotate it. So you give this 200 entries and get them to annotate and tell us whether it's actually cyber aggression or not. And the 2% doing that. And so based on that, we need to make sure that they are in agreement. So based on this, we then use it as a training set. So 0.6 Cohen Kappa agreement means it is quite substantial. So we agree by much. So then in these 202 random entries, there were 141 aggressive statements and then 61 non-aggressive. So a bit not so balanced, but because in the interest of time, we had to train it with some data set. Once we have done that, then we use whatever model that we have trained and use it to categorize 430 random entries from the same Facebook post. Okay, are you still following me? Yes, okay. Okay, so how do we do this? And again, we're not going to bore you with the detail, but really we use what we call the Lexicon enhanced rule-based method. It's a rule-based method, but we refer to existing dictionary for the bad words. So we use various lexical, swear word, senti word next, slang dictionary, positive word lexicon, emotion, and emoji sentiment. Okay, so what is the process? We will extract the document. So we extract the document from the social media post. We need to do a lot of cleaning up. And then once the text is clean, we will then process it, and then we'll work out the score, and then we'll then classify the text to whether it's a cyber aggression or not. Okay, so I'll let Stuart continue with the slight detail of the processing.
Thanks, Pat. So the process that we went through, Pat's just shown you those multiple stages. When people write on social media, they don't write beautifully crafted, grammatically correct sentences of the type I'm sure you all write in your reports and assignments. We get stuff that looks like this. And the double backslash and then the long string of numbers is a computer code that represents an emoticon. So with something like this, what we've got to do is go through and try and work out what somebody was trying to say. Clean that up. A lot of the previous research had only looked at the text elements. They'd stripped out all of the emoticons and emojis, but you lose a lot when you do that. So on the top there, you can see the computer representation of the first post, and then the second one is after we've cleaned it up. We extracted out the text, and then we have the emoticons and the emojis at the end. The other thing is that words by themselves are not enough. We often use modifier words to enhance the meaning, and sometimes to negate the meaning. And so the next stage to go through is working out which phrases belong together. And you can see in that middle sentence, not ugly is a positive sentiment, as opposed to ugly if we were just looking at the individual words, which would be a negative sentiment. So we've got to break up the text to work out which bits go together. And then you've got more complicated sentences, like the bottom one, where the words of interest are separated within the sentence. As Pat mentioned, we don't write beautiful words when we're communicating by text or social media. We use a lot of shorthands and codes. And so we've got to resolve all of those into words that are in our dictionary. We've got to collapse elongated words, and we've got to swap out misspelt words or words that are similar to each other, but one spelling doesn't match in the dictionary. And then, so that's our text normalization. And then we've got position of speech tagging, so identifying the different types of words, what they're doing in a sentence. So you can see all of those have been tagged there. And identifying punctuation and the end of sentences and things like that. So once we've cleaned up our text, and so that's not doing anything, that's just getting to a point where we can start doing something, then starts the analysis process. And emojis, remember, are text smiley faces, and emoticons are the graphical ones. They're represented differently in our computer code. So the emojis appear as the individual punctuation characters. The emoticons appear as a numerical string which represents the image that they belong to. All of those emojis have a ranking and a sentiment score, so they can be a positive or a negative thing. And in the same way that with letters being in words multiple times or enhance the meaning, people will often repeat emoticons to enhance things. So what we're doing is going through scoring those emojis, and where there are repeated emojis, we're actually adding extra weight to that. So we're uplifting that by 10% to say there's a really strong feeling there. In this work, emojis that are not in the emoji lexicon, we've just ignored, so essentially assumed were neutral. Those lexicons tend to get updated over time as new emojis become prevalent. Emoticons, in the analysis that we did, it was less common to see repetition of those, but we're still going through and doing the same sort of +1 or -1 sentiment analysis with those, and then going through and looking at the text and coming up with an aggression score. So that's both looking up all of those words in a dictionary to find out whether they've got a positive or negative sentiment, but also looking at the words around them to see whether there are things there that will change the meaning of that sentiment. We're not always looking for bad things. Sometimes we want to see if there are positive words in there as well. So we're also analysing the text for positive words using an existing system called the SentiWordNet to come up with an overall sentiment score for the text, and looking at all of those modifier words that exist to see if they change the meaning. And that's the words and also the sentence structure and punctuation. So we've gone through and processed the different aspects of our text, and then we come up with scores for these different things. Then what we've got to go and do and say, well, is that someone being positive? Is that someone just having a bit of a negative statement? Or is that actually a aggressive cyber aggression or cyberbullying thing? And so this is a set of filters. So you think of a range of funnels, sort of with words or the sentences flowing through them. Some are being filtered out because we've deemed that they're okay at that point. So what we want to do is in these stages get rid of as many positive things as we can, as early as we can, because we can say, hey, that's all right, that's a positive sentiment. So we do that, and then we go through and deal with the negative ones. So what we're looking for here is the overall balance of the sentence. Sometimes we will use a negative word, but actually overall the sentiment is largely positive or neutral. We don't want to immediately classify something just because it has one negative element as cyber aggression or cyberbullying. So all of these different classifiers and filters are trying to weed out the things that aren't really cyber aggression and cyberbullying, and at the end, if we get to a point that the sentence is still scoring badly, then we're going to mark that as being an aggressive text and flag that to the system. So how well did we do? How well did this approach go against other people's approaches in actually detecting stuff? So using your training data set, you would hope you do well, because that's the data that you've been using to train your system to program it. If you haven't done well with your training set, then there's something really bad going on. So we did pretty well with our training set. And you can see how one of the other pieces of work that Pat talked about, Reynolds et al., their comparative scores. So we're doing an awful lot better than they did with their algorithm. But then this is then the performance against our testing data set. So this is 300 or just over 350 entries that had been annotated, so marked as whether they were cyber aggression or cyberbullying or not. Just a reminder of what the TP, TN, FP and FN mean. The ones that we want is we want things to be true positives and true negatives. Those are the ones we got right. The false positives and the false negatives are the ones that we got wrong. Our data set was split into three different categories. So two data sets of 100 and one of 156. So you can see that the middle two columns show you the total actual positives and the total actual negatives in the data sets, and the ones on On the left of that are our results, and on the right-hand side are our scores. So 81% accurate for the first lot, up to 84% accurate for the third data set. And the F1 scores are all well over, or sorry, are at or about 85%, so average of 86, which means we're doing well. You can see that the recall is high, which you're keen on your precision and recall being high, but having a good recall is good. Just looking at the raw numbers there, you can see in data set 2, where we had 100% recall, we got 58 true positives out of 58 actual positives. So that's why that's up there so high. So this is comparing our training data set against our testing data set. You can see that actually we outperformed our training data set in pretty much everything, apart from recall, where it's slightly down, but still very good. So essentially, at the end of this, we can say that our algorithm worked well on the data sets that we tested against, which means that it's worth investigating further and applying to more social media posts to validate that. Bringing in the emoticons and emojis really helped in detecting whether things were cyber aggression or not. And we added in quite a lot of different features as part of this to like looking at the elongated words, the emoticons and the emojis, to try and add more nuance to previous approaches which had really just concentrated on using the text. We're happy to take any questions.
Thank you very much.